Hello everybody, my name is Reinout, I'm product manager at Skyline.
And I'm Jens, I'm a system developer at Skyline.
And today we want to talk about our demo platform, and in particular the networks and facilities demo domain. Because if you go to our demo platform, you'll see that we have here under the solutions view 4 different demo domains. And what's a demo domain? Well, we want to create a very realistic setup in those demo domains that really represent a realistic network that works like a real operation would do, where we can deploy our solutions to demo and to test if everything works as expected. And so today we want to talk about the networks and facilities domain, which is basically going to be our demo domain to demo everything related to networking across different locations, doing maintenance on equipment and links, for example, booking connections across the locations, and all of those things. And in there we've created a simulated network, which I can quickly show you. It's a multi-site network. It's a spine leaf structure. Here I have a detailed map, let's say, of that network. And we have a couple of locations in there. If I zoom in a bit, you can see that we have some equipment in LA, some in Tokyo, some in New York as well. It's a spine leaf structure. You can see the spine switches in purple, the leaf ones in blue, and then we have our edge chassis as well connected to those leaf switches. So this is a bit the structure of that network. And now we'll have a bit of a closer look in how we exactly built up this complete network. And for that, Jens, you can probably give some insights into our connectors that we've built for this network.
Okay, so one of the connectors that we've built was a switch, and all of this is simulated, and it's all monitored by IDP. So we managed to have this added in the IDP solution. Also, something that we did in here to start with was injecting LLDP information. And based on this, the IDP solution reads it out and creates DCF connections. To show you this, if I open this table, and for instance, here I have 4 entries linked to my spine. So from my local ports 49 till 52, when I look at my DCF connections of this element, and I go to those local ports, so 49 I set, you will see that we have links to this spine. So if we now have a look at the visual page, what we see over here is all the Ethernet ports that we have, together with some alarm statuses and some KPIs over here. Also at the top, we have some KPIs like CPU usage. You can click on the trend. You see by default the trend chart of the last 24 hours. Same for the memory usage. And when you click on an Ethernet port, you see some additional details. For that specific one, like now my 3rd Ethernet port is loaded, but if we go back to my first one, you will see over this one we have a bitrate running. So we have an incoming bitrate of 270 megabits in here. What can I do over here? I can toggle my admin state port. So if I just drop it, you will see down my bitrate drops over here. Also, maybe if you noticed, there's an alarm over here because this is my outgoing port, so there's a flow going through my switch, and I just turn down the admin state, so my flow will be interrupted. I'll show you that in a bit. I'm just going to start my admin state again.
So yeah, we can also see here on the ports, as you just showed, that we can convert those LDP connections into our DataMiner DCF connections. You can also see on the ports that there's a small indicator on those ports that we have a physical connection on, that there's a small cable indicator. that shows that that port is physically connected to something else, just to add.
Indeed, and we can actually simulate that that we unplug an Ethernet cable. So like for the first port, if we go to simulation, we can say we're going to disconnect this. And now we see the icon, connection icon is gone, and also operational state changed to lower layer down. And we can connect again. Also notice on this outgoing port, we have a small alarm now because there's no bitrate going through it.
So the small indicator indicates more the status of the bitrate going through it, while the color of the port itself is more controlled by the admin state and the operational state.
Yes, indeed. If we now would go to the other element, to our spine element, we will see that on a specific port, the fifth one over here, we were expecting a bitrate, but here we added the state unexpected low because we were expecting a bitrate of 270 megabits and now it's 0. And when I would connect my cable again, you see it all goes to green again, and here it goes to normal. So this is just playing with the admin state port and playing with the Ethernet cable. Something else that we can do is adding an additional multicast. So in this case, there's a multicast on port 1 and it has a bandwidth of 10,000 megabit. So if I now just would add a multicast on this interface, and the outgoing interface doesn't matter really, I'll just pick 10 because that one is operational. And in this case, I'll add, for instance, a bitrate of 10,000, so the maximum, but I'll give it a label. I'll just put my initials, and I'll make sure it's the same service class like the current flow. So if I have a look, my current flow has a service class of broadcast video. I'll just take the same one.
So that existing one, that's basically a service that's running in our network that we expect there to be. And now we will add something, based on that switch that we don't basically expect.
Yes, indeed. We will add a ghost flow. And now I'm going to execute. And what you immediately see on this port, we expect 270, but now it went to 262. So we simulated also with this connector packet drop that happens. So you see over here, my ghost multicast is added, but you also immediately see that this has influence on my spine, because here he's expecting, and we can have a better overview of that in our multicast table. We're expecting 270, but we are only receiving 262.
Because of the packet drops on the leaf port.
Indeed. So this is just a packet drop because of the easy to simulate, because we use the same service class. We can also do that when using another service class, but then when a higher priority service class is chosen with the 10 gigabit, all will go to that ghost flow and the other receive nothing. And that's something that I can show. I'm first going to delete this ghost flow and adding a new multicast again. So outgoing on this port, 10,000 again. I'll call it 2. And instead of broadcast video, let me take network control in this case. If I now execute, you will see my outgoing signal drops to 0, while my network control has everything in here.
So we take into account the service class as a priority to drop packets or not on the flows.
Yes, like a real switch does. And in case I would have multiple ghost flows created, I can just click delete all ghost multicasts, and all the one that we manually added are removed.
Okay, so we had in the network indeed built up of those spine and leaf switches, but we also have some edge chassis to process signals. Maybe we can have a look at the chassis as well.
Yes. If I open a chassis in here, it's actually, the chassis itself is built on top of the switch. So we first made the switch connector. All functionality of that is also available in the chassis with addition of cards that we plug in. So in this case, we have a chassis full of IP cards. We also have a satellite card and an SDI card. And in this case, you can click on an Ethernet port and you see the same information like we had on our switch in here.